Welcome to Lab 4. This lab is all about what to do when you have multiple data sets and you have some idea of how you want to combine them. And this lab is all about different options for how to do that. And you're going to practice your dplyr skills a lot in this lab. So the different ways to join the data sets are all under the umbrella of dplyr functions. And you're gonna solve a murder mystery. As cone 8, you're gonna practice the joins, and then cone 9, it's a little murder mystery for you to solve. And this is probably my favorite assignment that I give when I teach people. It's a lot of fun, but it's very challenging. This is a little bit of a stretch. Challenge wise. So please remember to get started on it early. You can't expect to do this lab like while you're watching TV or while there are any other distractions. This lab is going to take your whole attention. And I'd recommend like having a scratch piece of paper or something as you go, because it can be kind of nice to draw a picture or to write down what you expect to happen, and then verify that that's what's happening as you go. So you'll see what I'm talking about, but I'll quickly go over the reading, give a little advice, and keep this video pretty short because short amount of new knowledge, but a lot, I guess, a larger amount of thinking that you'll be challenged to do. And yeah, so please get started on it early so you can come to office hours if you get stumped. All right, so yeah, here I just kind of explain. All right, here we go. So yeah, this lab is all about what to do when you have multiple data sets. There's a couple of dplyr functions that you can use to join them in different ways. We're going to focus on left join only for this lab. There's others. I point you toward tidyverse documentation to learn about that if you're curious, but we'll only need one of them for this lab. So if you have two data sets, sometimes you just kind of want to mush them together. Let me explain what I mean. There are two functions called bind rows and bind columns, bind calls, that aren't actually joins at all. But I think that's a good starting point to talk about joins. So sometimes you have two or more data sets and you just want to like stack them up to combine them. So the first one is called bind rows, and it takes two tibbles. We're saying X and Y are two different tibbles. And I think of, so there's like a red tibble and a blue tibble, and you just want to stack them on top of each other to make a larger purple tibble. And I think like the way I remember that I need bind rows for it is I'm thinking I want to treat those tibbles as rows and just, this is the first row, this is the second row. Now we've got a bigger tibble. That's the image that I have in mind. So if we have two tibbles about students, again, there's 3 students here, and we have some information about them. And then we have 2 more students here, and we have the same information about them. So we have the people's study time and final grade, and then we have more people's study time and final grade. If you wanted to combine these two data sets, you would just stack them on top of each other, just like this, right? So you would look for bind rows and students A, students B. These are the names of the tibbles. And that would just stack them on top of each other to make a larger tibble with the data for all the students. So that's bind rows. And a rule is, of course, X and Y have to have the same column names. So name, study time, final grade. For you to be able to stack them on top of each other like this, you have to have the same variables, right? And then, so bind calls is kind of the opposite. Now I'm thinking about the red tibble and the blue tibble. Instead of going one on top of each other, I want to treat these tibbles like columns and put them next to each other. to form a wider tibble. So I don't know. I just have this, I kind of have this diagram always in mind to figure out if I need bind rows or bind calls. So if we have, for instance, students A is people's name, their study time, and then their final grade. And then students B is not information about other students. It's more data about these same students. Then we would want to treat them as columns here and just put them next to each other. So this is saying that Chris's number of failures is 0. Chris is not in a romantic relationship. And then Chris's first semester grade is 66.3. So you would use bind calls to put these two data sets together, and then you have a larger, wider data set with all the variables about all these people. So that's bind calls. So that's kind of one way to combine two data sets. And that it's often useful, but these are not actually joins. And so we won't practice bind rows or bind calls in these cones, or in the murder mystery. We're going to practice joins. So the difference is that I think of joins as kind of like you have two tibbles and you need to fit them together like puzzle pieces. That's my little diagram. So for instance, you have names here, and you have study time and final grade, and then you have names over here, and then you have different information about them. Failures, romantic relationship, grade 1. And you notice these people are not in the same order. Like this starts with Chris, and Chris isn't even in this data set. And then Courtney comes next over here, and then Courtney is at the bottom. So we need to kind of rearrange this data set by the same order that it appears here in order to put these two data sets together and make a wider one. So left join kind of puts preference on the left tibble or the first tibble. And so you'll get kind of a copy of the left tibble over here. But putting preference means we're going to have all of the rows that appear in the left-hand tibble in the result. And then it's just going to fill out the information coming from the right-hand tibble as we go over here. So this, like these first three variables are the same as in students A, and then we're filling out the information looking at students B. So let's not start with Chris, because remember, Chris doesn't appear in the students B. Let me zoom in and make sure everybody can see that. Okay. So Chris doesn't appear over here. So let's actually start talking about Courtney. So we've got Courtney. She's studying for 2 to 5 hours per week. Her final grade is an 89.7. And then what left join is able to do is it looks for Courtney's data over here, and then it fills out the information for her. So she has not failed any classes, she's in a romantic relationship, and she has a first semester grade of 84. And then so it does the same thing for everybody else. And then notice for Chris, it has Chris's information for his study time and final grade. And then since Chris does not appear in this data set, we're going to get NAs here, which means not applicable, which just means it's missing data. We don't know. Chris may have had failures or may not have. So that's what'll happen if it's missing data. You'll just get NAs. And then the syntax to call left join, you're going to have a left-hand tibble, a right-hand tibble, or so remember with the pipe, and this is how you're going to see it in the cones. We're going to say students A, and then pipe that into left join, comma, or so it'll be students A, pipe, left join, students B, join by name. So Here, the variable name is the key that these two tibbles have in common that allows us to match the information. So you have to say join by name. I say here the key students A and students B have in common is name. So I hope that's clear. One other thing I want to say about NAs, in the murder mystery, they kind of set it up so that it's easy to mess it up, kind of. If you don't join by the correct variables, you're gonna get, when you do your joins, you're gonna get a lot of NAs. If you do your joins wrong, you're gonna get a lot of NAs on the right hand side variables. So if you don't join by the right variables here, if you join by name and then failures, if you say that those are like that, those are the things that match up, then you're gonna get the first variables are gonna look okay, and then over here under failures, romantic, grade 1, you're gonna get all NAs because these variables don't actually match. So that's something to look out for. Always view, use the function view to take a look at your data sets after you've joined them to make sure that the join seems to actually be working. And then, so the cone will also have you do this, which is sometimes the variables are not named the same thing. So if we have our first variable, if our first tibble has name, study time, and final grade, maybe the second tibble, it doesn't have a name column, but it has a person column. And the person column here matches up with the name column here. And the syntax to deal with that, so you could rename, you could use select to rename this tibble to say this should be name, not person. That's one option. But another option is to use this. So instead of saying just join by name, you would say join by name. So name on the left-hand tibble is equal to person on the right-hand tibble. All right, let's see. I think that was all I was gonna say. Let me see. Oh yeah. So in the cone, you're gonna be working with, in the dplyr murder mystery, you're gonna be working with a lot of different data sets, not just two. This is part of what makes it so challenging. Whoa, that's me way too big. Get smaller. No, not like that. Okay. So, all right. Okay, so you're gonna have all these different data sets in the murder mystery. And I link you this URL to go and look at this diagram. And this diagram is called an entity relationship diagram, or ER diagram. And it shows you the variables that can be used to link the data sets together. So there's all these different tibbles, all these different data sets, and the arrows tell you, okay, the get fit now check-in, the membership ID variable can be linked, it can be matched with the get fit now member ID variable. So that's what these arrows are. So definitely take a look at this diagram if you're wondering how to match these different tibbles. It's all right here. And then let's see. Yeah, so the ER diagram, keep a scratch pad next to you and draw pictures and write down the variables that you expect to see after you've done your joins. Use view so that you can see what your joins make and make sure that if there's a lot of NAs on the right-hand side, your join failed. You did not join by the correct variables. And then, last thing I wanted to say is I have tests. There's a test file for Cone 8, which teaches you a little bit about doing left joins. And then there's no test file for Cone 9. So if you try and run Command-Shift-T in Cone 9, you're gonna get no test files are found because there's no test files for Cone 9. Cone 9 is the dplyr murder mystery. I didn't want to even let you have a test because I didn't want there to be any spoilers. So there's no test files for Cone 9. There is one for Cone 8, none for Cone 9. But with Cone 9, I give you a link to a Google survey that I made. And it asks just to be able to check your answer to the final question. Who did the murder? And even if you're really, really confident about your answer, I want you to do not skip that survey. Because the survey gives you something kind of cool. So don't skip the survey. Verify that your final answer to the cone is correct. And have fun, and please don't let yourself get to the point where you are unbelievably frustrated with this one. Start it early so you can come to the office hours. And have a great week and enjoy this amazing weather we're having.